All right, guys, everybody should have their notes pulled up. We are going to talk today about compositions of functions. Yesterday, we talked about combinations, where you're just adding and subtracting, multiplying, dividing, finding domain, and stuff like that. Today, we're going to find compositions. And what that means is you are going to have one entire function that you are going to plug into another function. So one function is going to be composed of another. You're not just plugging in a number into two functions and then combining them. You're actually taking a function and plugging it into another one. So the way that that is written is right here. Two different ways you will see it written. F of g of x is what that says. Doesn't say fog, and that's not multiplication. Do you see how the dot is open? It says f of g of x, or it can be written f of g of x like this in the double parentheses. Everybody see that? Right here? You guys see what I'm talking about? Okay, so the way that you work these problems out is I'm going to write this down. You need to write from the inside out. All right? This concept is not difficult, but it can be confusing if you just try to do everything in your head. If you follow along, you don't have to every time, but at least from the beginning here, when we're trying to, kind of get a handle on things, it's easier if you draw yourself a little tiny picture. I'll show you what I mean by that in a second. There's one question from your homework that I want to go over last night. Guys, if you get stumped on something on the homework, there's a place on WebAssign where it says message your instructor. Some of you did that, and that's fine. I actually saw it this morning. I usually don't see those. So if you do have an issue, there were some other people who just took a screenshot of the question and then wrote me a little note and emailed it to me. That's the easiest way for me to be able to get back to you, because for me to go on to WebAssign, I don't usually do that. So just send me an email with your question and I can answer from there. But I'll go over one of them that a lot of people had questions on. But when we talk about compositions of functions, you're actually taking one function and plugging it into another. When I say work from the inside out, do you guys see how g is closer to x on the inside? Same thing here. It's on the inside of our problem. You're going to take, when it's written like this, you're going to take the function that's closest to the x and plug it in this outside function. Just like here, you would take the g and plug it into the f. And I'll show you in a second. Like if you notice here, these two functions, do you see how it says f of g of x? They took the g function, which is right here, x plus 1, and they plugged it in to the f. That's what we're going to be doing. Sometimes your answer will be left in terms of x. Sometimes your answer will have a numerical value. So I'm going to show you both of those situations right now. All right, when I look at this first example, I'm going to do a and b in terms of x, and then we're going to do a and b when we have values to substitute in or to evaluate with. So when I first look at this first question, first thing I do is I'm going to rewrite my functions. F of x equals x plus 2. And then g of x equals, God bless you, 4 minus x squared. So when I look at a, this can also be written like this. F of g of x, right? Same thing. Those mean the same thing. Which letter is on the inside? G. That's the closest to the x. Is my answer going to have x's in it, or is it going to have a numerical value? X's, because there's no number. They didn't tell me to plug anything in. So what you're going to do is you are physically going to take the whole g function and plug it into the f. So watch. This is how I always do these problems. This is how I'll do your answer key. I'm going to take the g function and plug it into the f function, where the x value is. So instead of writing x plus 2, I'm going to replace the x with 4 minus x squared. Everybody see that? And then you just finish, you write plus 2. Can we combine like terms? Yeah, I have a positive 4 and a positive 2, right? So that gives me negative x squared plus 6. Somebody last period said, can I write it 6 minus x squared? Sure, same thing. But that would be your composition. F of g of x equals, when I take the g and plug it into the x, this is what it equals. You are taking one function and plugging it into another. You're not adding them. You're not multiplying them. You're substituting one function into the other. So when I look at the next problem, it looks like it's the same thing, but the letters are reversed, aren't they? I can rewrite this as g of f of x. Well, what letter is closest on what's smushed on the inside? The f. So that means in this case, I'm going to take the f function and plug it into the g. So I'm going to get myself organized, and I'm going to say, okay, I'm going to take this whole f function here and plug it in to the g. So my g function is 4 minus, instead of x, what am I plugging in? X plus 2, good. And then I have quantity squared, so you can go now. Now, when I evaluate this, guys, what does x plus 2 quantity squared mean? Foiling. Means you're going to have 2x plus 2's. So watch, be careful with signs. I have 4 minus, I have x plus 2 times x plus 2. So my 4 stays out in front here. If I FOIL this, x times x is x squared. X times 2x is 2x. And then if I have 2 times x, it's 2x, which gives me how many? 2x, I'll write it out. 2x plus 2x plus 4, okay? Now the 2x's combine, I have 4 minus x squared plus 4x plus 4. Do you guys notice that I kept that trinomial, x squared plus 4x plus 4, in parentheses? Why did I do that? If that was the plus sign in between the 4 and the parentheses, you didn't have to. But since that negative is there, it's really important to remember, there's a negative. I have to distribute it to everything inside here. So boom, boom, boom. So this becomes 4 minus x squared minus 4x minus 4. So when we combine like terms, what happens with a positive 4 here and a negative 4? They cancel. Good. So what are you left with? Negative x squared minus 4x. Right? My answers are different. Those are not the same thing because we didn't do the same thing. In one problem, we took the g, plugged it into the f. In the other problem, we took the f, plugged it into the g. We went backwards. Does that make sense? Yeah? We okay?
Can you further factor out the x, like the negative x?
You can if you want to, but you don't have to. Now, if you were given these same two functions, all right, I'm going to rewrite them. We'll make a little pretend problem here. F of x equals x plus 2. And then g of x equals 4 minus x squared. All right, we're going to do two problems here. We're going to do f of g of negative 3. And we're going to do g of f of 4. Okay, how is this different? How's this problem different? I have a value. Okay, we're going to do the exact same thing that we just did a second ago. We're going to work from the inside out. So what we're going to do first, guys, what do you think we're going to do? We're going to take negative 3 and plug it into the g function. All right, so I'm going to say, okay, what is g of negative 3? So 4 minus x squared. So I'm going to say 4 minus negative 3 squared. Well, what's negative 3 squared? 9. So 4 minus 9 is? Negative 5. So what do you think I do with that? Yep. We found out that g of negative 3 is negative 5. So now you're going to take this value and plug it into the f function. So we're going to say f of negative 5, and we're going to use x plus 2. So we'd have negative 5 plus 2. So my answer here is what? Your whole answer is negative 3. Negative 5 is getting you halfway there. You're taking the value that is closest to the inside, that negative 3, you're going to plug it into g. See what that gives you. Then you take that value and plug it into f. Does that make sense? So if we do it reversed, g of f of 4, well, circle it. Show yourself exactly what you're doing. What are you doing? You're finding f of what? F of 4. So I'm going to say f of 4, and I'm going to use x plus 2. So 4 plus 2 is 6. Great. Is that the answer? No, because I now have to take 6 and plug it into what? to the g. So when I do that, I have g of 6. And what is my g function? 4 minus x squared. So I have 4 minus 6 squared. What's 6 squared? 36. So 4 minus 36 gives me negative 32. Perfect. So when you have g of f of x, f of g of x, that means you should have x's in your answer. You're going to take the function that is closest on the inside, closest to the x, and take that whole function and put it into the other one, or vice versa. If you have a number, you take the number that is closest with the letter, stick it into that function, evaluate it, then you take that answer to plug it into the outside one. Work from the inside out. Does that make sense? You guys okay? All right, a couple more examples. Let's scoot on over here to 5. Let's talk about what this says. First of all, it says find what? What's the first thing you say? Find f of g of x. Not multiplication. If it's multiplication, they would just stick them together. So what they're asking you to do is take the what? Take the what? The g and plug it into f. All right. Now, before we do any of this, before they do any of that, there's two values they want us to use, and it says if possible. Okay. Now, when you look at this, there's domain, we'll call it restrictions here. What does that mean? It says square root of x where x is greater than or equal to 0. What is that telling you? What is it telling you about your x value? It's not going to be less than 0, so it's not going to be a negative number. You guys see that? Yeah. In the second one, they're telling you that your x value is not going to be what?
0 or
It won't be 0 or a negative number. It won't be less than 1. Can be 1, but it won't be less than. All right, now, some of you are like, okay, who cares? I'm just letting you know that if you see a problem like that and there's a restrict, that doesn't mean you're not plugging in an inequality. That's just stating that what the domain of each function will be for this problem. Now, this question says find f of g of 2 and f of g of 0 if possible. If it doesn't work, if it's not possible, you guys would say that. So f of g of 2, and then over here we're going to find f of g of 0. So the way that you would work this out, the way that you would show me you know what you're doing, is what? We're going to plug 2 into g. So the first thing I'm going to do is find g of 2. My g function is x minus 1, right? So 2 minus 1 is 1. Agreed? Now what do I do with 1? I'm going to plug it into the f function. So now I'm going to find f of 1. I'm going to use the square root of x. So when I plug in the square root of 1, I get what? 1. Is that an okay answer? Yeah. Okay, that's possible then. No worries. Good. Now with the second example, g of 0.
So what happens if it was less than 0?
Hang on one sec. Let's do this one, okay? Let's do g of 0. I'm going to take g of 0. Well, tell me, explain to me what I'm going to do here. I'm going to use the g function and plug in 0. So I have 0 minus 1. Well, wait a second. Okay? Wait a second. Max already looked at this. Wait a second. My restriction here with the g function was my x values were going to be greater than or equal to 1, right? Is 0 greater than or equal to 1? So at this point, you could say, oh, this is impossible. I can't do it. But if you were ignoring this domain restriction and you didn't really understand what that meant, just continue on. If I take negative 1, which I just found, right? What do I do with negative 1 if I was going to continue the problem? I'd plug it into the f. So I'm going to go right here. I'm going to say, okay, f of negative 1. Well, I'm using the value or the expression square root of x. So when I do this, I get the square root of negative 1. Is that possible? To get a real answer? No. The square root of negative 1 is I. We're talking about real values. We're not talking about imaginaries right now. So in this case, you guys would say not possible. So at this point, Max, where you saw, wait a second, you just said we can't have that, you could stop right there. But if you didn't and you continued to be like, oh, wait, yeah, that's not going to work. Good job. Okay, the last thing I want to talk about, we are not going to do example 8. The reason why is this, example 8 leads us into inverses, which is section 1.6. We generally teach 1.1 to 1.6 and take our first test on it the Tuesday after Labor Day. That's not going to work this year because we have our 25th anniversary Archbishop Wensky Mass on Tuesday. So we took off 1.6. That's why our test is a little earlier, because it's a little shorter. So we're going to take inverses and just stick it on the next quiz. So this leads us into inverses. I'll do it when we start inverses. So you guys can cross off example 8. We're going to do that. We are going to do domain, though. This is like everyone's favorite thing in the whole world, I know. All right, find the domain of f of g for the functions given. Two different functions. If I were to make a composition of them, it would create one function, right? So let's talk about these domains individually first. What is the domain for my f function? What is it?
Or negative infinity.
Negative infinity to positive infinity. Why is it all real numbers, as you guys want to say? Why is it negative infinity to positive infinity?
It's not a fraction. It could be anything.
It could be anything, right? I could plug in any negative number there, because when I square, it's going to become positive, and then I just subtract 9 from it. I can plug in 0 and subtract 9 from it. I can plug in any positive number, square it, and subtract 9. I get an answer. What's the problem here? All right, we cannot have the square root of a negative number. So now we have to do a little bit of thinking. Okay, yesterday, there's an algebraic way to figure this out, which I'll show you in a second. But if we had a denominator like 1 over, 3x plus 2, we would set the denominator not equal to 0 and figure out what that value would be, correct? Okay, so we can do something similar here, but we can't set it equal to something. What would we have to set this expression to?
To 0.
Can't be, you don't want it just, because it's more than just one value, right? That could fit in there. So not just 0. Can it be anything less than 0? Can that expression be less than 0 underneath the radical? It has to be greater than or equal to 0, correct? Okay. Little side note, if you had 1 over the square root of x, what would you set the bottom to? Would it be greater than or equal to? It would have to be what? Not just itself. Could I have the square root of 7 on the bottom? Yeah. Could I have the square root of 9? Could I have the square root of 1? Can I have the square root of negative 12? No. Can I have the square root of 0? No. So it can't be greater than or equal to. It has to be just greater than. If you have a denominator that has a radical, it's just greater than. It's not or equal to. Yeah, since that is in the numerator, this is over 1. This is just an expression over 1. It's greater than or equal to. So now if we solve this, right, this isn't going to tell us the exact answer, but it's going to give us some things that we can think about. How would I solve this? 9 minus x squared, the square root of 9 minus x squared greater than or equal to 0. What would I do to both sides? Square both sides, okay. So I have 9 minus x squared is greater than or equal to 0. I like to keep x's on the left-hand side, so I'm going to subtract 9. So I have negative x squared greater than or equal to negative 9. What's the problem there? They're negative, so I need to divide by negative 1. Guys, when you divide and you have an inequality, what happens to the inequality sign? You divide by negative. It flips. And now what do I do? Take the square root. Okay? So I'm just telling you x values have to be less than or equal to plus or minus 3. Now last period someone was like, what in the world does that mean? How are you less than positive and negative 3? What? Okay, so all that is just giving you some things to think about, right? Let's just think. I have negative 3 here. I have positive 3. What kind of dots am I going to have at negative 3 and positive 3? Why? okay? Because it's a solid or equal to, all right? Now let's just think about our expression. 9 minus x squared, it's underneath the radical. If you don't know which way to color, what it includes, let's just think about it. Pick something to the left-hand side of negative 3. Any number to the left-hand side of negative 3. Negative 4, okay? If I plug negative 4 in here, what's negative 4 squared? 16. So 9 minus 16 gives me what? A negative. So is anything on the left-hand side of negative 3 going to work? No, okay. What about if I plug in negative 3 itself? What's negative 3 squared? 9. What's 9 minus 9?
0.
Is that okay? Yeah, it's not in a denominator, so we're good. All right, let's plug in something in the middle. How about 0? What's 9 minus 0 squared? 9. What's the square root of 9? Okay, so that works, right? What about positive 3? Can I plug in positive 3? Right. 3 squared is 9. 9 minus 9 is 0. Square root of 0. Okay, fine. All right, pick something to the right of 3. Any number. 4. What's 4 squared? 16. What's 9 minus 4? Squared. What's 9 minus 16? A negative. So is anything over here going to work? No. So where are the only values going to satisfy our g function? Between negative 3 and 3. So my domain is not going to be negative infinity to positive infinity. It is for our f function, but when we have a composition, when one is going to go into the other, we have to find the domain for both. And then remember, we talked yesterday about the overlap. So your domain would just be right here. How would I write? I can use anything from negative 3 to positive 3, and it includes it. Bracket, good. Negative 3 to positive 3. Very good. So a lot of times, guys, it's helpful to set, if you have a root greater than or equal to 0, or if it's in a denominator greater than, but to just give yourself some testing points. So you know, okay, here, I can draw a number line, and I know that 3 and negative 3 are my boundaries. I just don't know what it includes or excludes. So just use some mental math, and you guys can figure that out. If you had the cube root of something, could x be negative? Are there any domain restrictions right here for what I just drew here for the cube root? What's the cube root of negative 8? Negative 2. You can take the cube root, you can take odd roots of negative numbers. 5th root, 7th root, 9th root. You just have domain restrictions when it's an even root, like 2, 4, 6, 8. So just kind of keep that in mind.
So if it was an odd root, it would be the infinity?
You can plug in anything.
What would it be if it was like negative 4?
If it was what?
4, like the cube root of 4.
It's something. It's gross, but it's like 1
So
point.
we don't have to,
No. You just need to know that it will give you a real number. You can have a negative odd root underneath the radical. Yeah.
So what I'm saying is, how do we write that? Like,
Negative infinity, positive infinity.
it doesn't matter.
You can use anything. All right, so that's it. That is all that's going to be on your test. I'm about to upload this video in just a minute. But I do want to go over one question that I had 3 people that emailed me about it last night that they were lost. So I just want to go over it just to make sure you guys are aware. It's from last night's homework.